Plenty of seats in the front row.
Yeah, come down. Okay. Welcome to this forum this afternoon. I hope some of you do not have to cut classes in order to come. So this is hopefully the beginning of a new sort of forum, a new series that will go on, and we'll see how that goes. The idea is I was talking with various faculty and departments just in the last few weeks. As you know, I've been here only for about 5 weeks. Obviously, we as a university have a lot of distinguished scholars who comes and visit us on a regular basis. Now, most of them usually gives a talk, usually a technical talk in their field of expertise, and typically that will, is intended for sort of the experts, maybe faculty and students from 1 or 2, maybe even 3 departments. That's sort of the idea. Some of these, of course, is technical and may not be accessible to a bigger audience. And I happened to actually run into 2 of these visitors recently. Sir Michael Atiyah is one of them. And I happen to know these people personally. And behind the science, behind the engineering, behind the scholar, there is a life behind these people. And I thought actually many of these stories should be very inspiring, especially to our students. I think so. The purpose of this series is where we would just have a conversation. Okay, it doesn't have to be me every time, but in this case, it happened. I'm a mathematician, so Michael is a mathematician. I thought this would be a good way to start. And so, really, in a way, this is intended primarily. Well, of course, it's for the university community in general, but one of the prime objectives is to hopefully this will be appeal to our students. Hopefully, the speakers, their life stories, will be an inspiration to our younger generation. That really is the motivation behind them. So, with that in mind, the way we're going to proceed with this is I will give an introduction, and I would not go into the scientific work. Will not make according to the principle I just explained, but I will try to highlight some of the other aspects, in the official biography, so to speak. I will try to do that. Then I will go over there. I will maybe ask a few questions to get the audience warmed up, okay? And to also get the speaker, have a chance to say a few things first. And hopefully I will leave at least 20, 25 minutes for the audience to ask questions. That really is the idea. We have never done this before, so we'll see how it goes, okay? So I make sure, so starting now, you should think about questions that you might want to ask our distinguished guest today, but try to stay away from the technical aspects. Okay, I think that would be really good. So let me start by introducing Sir Michael Atiyah. So I will do the long version because we try to touch on different aspects. Yeah, please come down. Yeah, come down all the way. Now, first of all, I should say that really, Sir Michael Atiyah is really one of the most well-known, most influential living mathematician. I should just say that. Okay, so okay, don't want to go back to history and all that. Anybody in our field of mathematics would know Sir Michael Atiyah's not only name but also the contributions. Okay, that's not easy to say. So I want to get that out of the way. He has won basically every medal that is there to win for a mathematician and beyond. He's won the Fields Medal, as you know, that's sort of like the Nobel Prize for young mathematicians. More recently, he has also won the Abel Prize, which can be called the Nobel Prize for not so young mathematician. Okay, is that fair enough? Okay, is that fair enough? Okay, so, and then many, many medals in between. Okay, so I don't want to go through the list. So coming back to this long version, which we got off the web. Okay, so Michael Atiyah's father was Lebanese, and his mother was Scottish. His school education was partly in Cairo, and then after leaving, he attended the Victoria College. It was in Cairo, I assume. By the way, I went to Queen's College, which is across the way from Victoria Park. So there's some connection there. I think it's the same. It's the same Victoria, I think. Okay. And then also the schooling partly in Manchester, at the Manchester Grammar School. Okay. So after leaving school, he did his military service, which was compulsory at the time. Then he entered the Trinity College in Cambridge. Later, he became actually a master, I think, of the Trinity College. So in fact, he did his bachelor's degree in Cambridge. And yes, he did. And then also the doctorate. He was then made a fellow of the Trinity College in 1954. He spent the year of 1955 at the Institute for Advanced Studies in Princeton. As you know, is related to the IAS that we are doing now at HKUST. He was there as the Commonwealth Fellow at the IAS there at Princeton. After he returned to Cambridge, he was a lecturer, then a fellow of Pembroke College. He remained at Cambridge until 1961, when he moved to Oxford, where he became a fellow of the St. Catherine College. So he has been both at Cambridge and Oxford. I'm going to ask you some questions about, that rivalry, maybe. He held the prestigious Savilian Chair of Geometry at Oxford from 1963, holding that chair until 1969, when he was appointed professor of mathematics at the IAS at Princeton. So he went back to Princeton. After 3 years there, he returned to England, becoming a Royal Society research professor at Oxford. He was then elected fellow of St. Catherine College of Oxford. So Oxford was remain Sir Michael's base until about 1990, when he became Master of Trinity College at Cambridge. And then at that point also, he became director of the newly opened Isaac Newton Institute for Mathematical Sciences. This is in Cambridge. I actually personally visited that institute. Is one of the most well-known and influential mathematics institute in the world, actually. It's a beautiful campus, the new one. It's very, very beautiful. Now, Sir Michael's work, without getting into details, obviously, as you said, he was the professor of geometry. So this is mainly. But his work actually touches on many aspects of science outside of mathematics. As you know, geometry is very much tied to physics, relativity and other things. Gauge theory, some of you might know that. And also, more recently, to particle physics, to string theory. There's a lot of geometry in string theory. So I think Sir Michael should have a kind of unique perspective on how different areas of science sort of interact with each other. Now, later on, he was elected a fellow of the Royal Society and then became its president from 1990 to 1995. So the Royal Society consists of all kinds of scholars and scientists, not just mathematicians. So Michael was the president. I think that would also provide a unique perspective as well. So I think maybe one more thing I want to mention is that Sir Michael has been elected to as a foreign member of many national academies. And that includes the United States, Sweden, Germany, France, Ireland, India, Australia, China, Russia, and Ukraine. So I'm sure more will come. So that also gives him a very international perspective. All right, so with that introduction, let me come over here. Okay. First of all, thank you very much for agreeing to do this literally at the last minute. Let me tell you a little bit. Sir Michael was in town, first of all, as a visitor for our Institute for Advanced Studies, but also for the Shaw Prize, which was awarded last week. In fact, he was the chair of the selection committee, is that what it's called, for the mathematics prize as part of the Shaw Prize. So we were at the dinner together, I think it was last Wednesday, and we had just sort of hatched this idea about doing this, and I basically asked Sir Michael about, how about we start with you, next Monday? And he very graciously accepted. So I really haven't had much time to prepare, but this is supposed to be free flowing anyway. So the first question I have for you, Sir Michael, is that your life story really looks very interesting. I mean, father was Lebanese, mother was Scottish. You were born in Cairo, and you travel all around the world. You're part of the National Academy of all these places. I was asking Sir Michael at lunch today how many times he has been to Hong Kong. It's at least 10 times, that's what he said. So can you tell us a little bit about sort of the part of your life that is not really in the official CV? That's what really, okay, there's a lot of things behind it. You have a very interesting life story. What it appears, please.
Well, my background, as you heard, is really from the Middle East. My father was Lebanese. He worked in the Khartoum in Sudan. I grew up there, and then I went to secondary school in Egypt. My grandmother lived in the Lebanon. We moved also to the Lebanon. So until I was 16, I lived in that part of the world, although because my mother came from Britain, we used to go to Britain for our vacations. And so I spoke English, Arabic, and French. A very cultural situation. Lebanon was very much influenced by the French, Sudan, Cairo by the British, and everywhere else one spoke Arabic. So it was a very international atmosphere, and I think that makes a difference to your perspective in life. You grow with a broad outlook. And we traveled backwards and forwards to Europe every year. And then after that, when I came to Britain, had my education, then I thought I'd travel by myself, partly for pleasure and partly for mathematics. I traveled all over Europe. I spent many, many times, for example, the United States. I went so many times in the United States. When you go to the United States, you have to fill in a visa form. You have to then. And one of the little form about this big, and on one point it says, have you ever been to the United States before? If so, list all dates. On a little piece of paper like this. So after a while, I would say I've been more than 50 times. I left it like that, and they didn't ask any questions. Anyway, I've certainly been there at least 50 or 60 times, and I spent 3.5 years there on a permanent basis as well. But I've also been to Hong Kong a lot, surprisingly. China several times, India, Japan, all fairly lengthy times. India I've been to many times also. So I think I've had quite a lot of exposure to the world, and I like to think of myself as a world citizen. People ask me, where do you come from? I say, well, where do I come from? How do I answer that question? So I regard myself as a citizen of the world, and I think that affects your outlook on life. You're not too narrowly focused on one country or one area. So I like to belong to the world as a whole, and try to do what I can to assist. The level of science, mathematics included, is a very international occupation. We all work together, particularly now with the internet. I grew up before the days of the internet. I can just about do email, but that's not much more. So we mathematicians collaborate all around the world. I've written joint papers with people from all countries. We travel to conferences. And you feel very much that it is a collective intellectual endeavor, which we all work together for the benefit of mankind as a whole. It's of course always been international. You go back way to the times of Isaac Newton and Galileo, and it was much slower in those days. People wrote letters. They didn't have email. And they took a long time to travel. But nevertheless, there was a free flow of scientific ideas all across Europe. By the way, at that time there was not much contact with China. That's an interesting story. I can come back to that. China cut itself off from Western civilization at a certain point. After it had a lot of interesting science came into China, but then some emperor decided that it was dangerous to have too much foreign influence, and he banished all the foreigners. And from that point onwards, for about a couple of 100 years, China went backwards in science. It was the influence of the man on the top. But now it's opened up again. We're back to a unified world, so to speak. So anyway, international life is part of my whole lifetime. As you get older, it's a bit more difficult to travel, I'm afraid. But I keep still coming to Hong Kong every year. Hope to keep coming for a few more years.
Well, very interesting. I want to pick up on one point you just mentioned about this, the China closing off, its exposure. I just came back from this inauguration of KAUST, which is the King Abdullah University of Science and Technology. That was just 3 weeks ago. And, in some sense, you can think of it as the Saudi Arabian or the Arab world's version of HKUST or MIT or Caltech, if you will, right? So that's so for example, the king was there to inaugurate the university, and he mentioned three things. One is, the first two is like, the vision for our university as well, which is to train, students, in the area that we cover. Second is to hopefully diversify the local economy to have an impact on society and economy, which obviously is very close to what we do. But the third thing I thought was very interesting, which was, of course, is to resurrect, if you will, the contribution of the Arab culture to science, which was very prominent in the Middle Ages. And in some sense, the same thing happened, in the Arab world as well, where it was closed off. By the way, the little I know, like anything that starts with Al, A-L, in science is really come from the Arab world, like algebra, algorithms, and so on and so forth. I mean, just a little I know. So can you draw a parallel between the Arab world and the Chinese world from this perspective?
Well, it's a broad brush. I mean, certainly they have something in common. They were both ancient civilizations by modern standards, which had a great period flourishing hundreds of years ago, at a time when they were probably more advanced than Europe. And then things have changed. Europe advanced faster, overtook them, and for a variety of political and other reasons, they withdrew. Now they're having difficulties to reopen up again. So in that sense, there is a strong comparison, and in both cases there is a different culture, a different language. So there's quite a big gap between Chinese on the one hand, Western Europe, or between the Arab world and Western Europe, which, but I think going back to the contributions that these civilizations made in the past is very helpful. For example, in Britain at the moment, there's been quite a lot of activity to highlight all the contributions made by Arab civilization towards science, modern life. Most people are unaware, not only of the bits of algebra, but large numbers of things which were discovered and used originally came from the Arab world, and they've been trying to do some public relations, to explain these so people can appreciate. Because sometimes in Western Europe, people think everybody outside Western Europe is a barbarian. That was the view. And so it's good to remind them that, in fact, much of modern civilization rests on the contributions made by other civilizations a few hundred years ago. And the same is true of China. So I think there is a fundamental similarity. Yes, of course, there are big differences in other respects, but there is something common. By the way, I could just add to that little story about China and closing the doors of science. The nice story I read, this period in the 17th century, the times of Isaac Newton and so on, the people who came to China to bring the information about science were the Jesuits. The people who they came and spent, they were very scholarly people. They came to bring, but they spent most of their life in China. They learnt Mandarin. They became very influential. They advised the emperor, and in particular, they brought the new science, astronomy, with them. And one group helped the emperor. They built a telescope system to help them to identify the calendar, very important for agriculture. Then the next emperor, he kicked these out. They were dangerous, brought in dangerous ideas. They were all banished. And then another 100 years later, I think another emperor moved the capital north. You probably know when that would be. When he moved it north, he carefully transported all the astronomical instruments up and set them up exactly the same way in the north. And there was nobody around who understood the science then. Jesuits had all gone. Nobody realized that when you move telescopes a few hundred miles further north, you've got to recalibrate for the new latitude. So, of course, they didn't work. So it's a danger of getting rid of your scientists.
I want to explore a little bit this general issue of the relationship between science and scientists to society. Now, one obvious connection is, as I mentioned, sort of economic impact. Certainly that's, I think, to some degree, how Hong Kong society looks at science and technology. For example, our chief executive is going to announce in a matter of days, actually, right, 6 areas where Hong Kong wants to go into in terms of economic development, and one of them is science and technology, which, of course, UST, being S&T as part of our name, we should support. But I'm talking about interaction with the society in a much bigger, higher dimension. What are the social responsibilities of scientists? I understand, Sir Michael, you are, in addition to your scientific work, you are also sort of a socially active scientist. Can you talk a little bit about what you do and the perspective from that angle?
Yes, well, I mean, when I became president of the Royal Society, this is 1990, until that point I'd been mainly just a mathematician, but as president of the Royal Society I had to represent all science, speak on behalf of all scientific community. And so I used to have to think about the question, what is the relationship of science to society, what are the obligations of scientists, and so I began to form my opinions about what these are, and I thought very carefully that the scientists are there to, of course, for the benefit of society, and they have to develop. They have to be such that the public can trust the scientists. Scientists are there to discover the truth as far as they know, and let it be known, and educate the public, and be there to provide genuine evidence for or against different actions. So they play a very important role, and it's very important that the scientists should be honest. Sometimes there's a temptation to keep things secret. Not good for the people to know too much. And government, if you're too close to the government, there's a temptation to do what the government wants. That's not good either. If you start doing that, then the public will cease to believe you. If the public ceases to believe you, you lose your reputation. So it's very important that scientists and the whole academic community has to maintain its integrity. Even though it gets money from the government or from business, it has to reserve its integrity and say what it believes and publish it, whatever it finds, not hide things because they're inconvenient for the government of the time. That's absolutely fundamental for any academic institution. Once you start to turn things around and do what the governments want, then you lose your credibility, you lose a large part of your influence and function. So that's the kind of things I sort of learnt. I also became involved in the particular responsibility of scientists to advise on issues which involve science as it affects the public. Large parts of science are applied, have consequences, whether it's in technology or in medicine or other fields. What they do affects society. And quite complicated, difficult social and ethical questions that emerge about different kinds of medical treatment or about the use of information, for example, how much you keep information about people. So there are a lot of issues which emerge from science as it's applied to society, and scientists have a responsibility to involve themselves in this discussion and contribute. And the one area which I felt quite strongly about was to do with atomic energy and atomic weapons. And so actually I became president of what's called the Pugwash Conferences on Science and World Affairs, which was set up after the World War, mainly by the physicists who've been responsible for developing the nuclear bomb. And the aim was to stop the further development of nuclear weapons, to cut them back, to stop their use. And so I was president of this organization for 5 years. And it was a bad 5 years to be president. I coincided with the wrong president. If I'd been president now, I'd be much happier. Because the things we were trying to advocate are, of course, exactly what Obama is trying to do now, to work towards a world without nuclear weapons and so on. And it's the scientists involved in these organizations have tried for many years to press the governments to move this way, but it's hard work to get over nationalist feelings and so on. At the moment, I'm more hopeful than I have been for very many years. So these are the kind of things that I felt quite strongly about, and I spent quite a lot of time on them. I'm now retired from almost everything, but I still follow what's happening, and I'm very pleased with the new direction of world affairs.
What do you think about Obama winning the Peace Prize? Since you brought it up.
Yeah, I think it's unnecessary, actually. I mean, he was doing very well. He doesn't need the Peace Prize. Yeah, I think it probably would have been better if he'd waited a little bit, given it to him later. At the moment, I don't think it's even a help to him. It complicates his life. I think it's politically... I mean, I understand why the Norwegian Parliament gives us the Peace Prize, why they did it. And it's quite nice in its way. But I think it's probably the wrong timing. But, I mean, it's a minor point. The Peace Prize doesn't solve the problems of the world one way or the other. But I think it's not a major factor. What Obama does, how successful he is much more important.
I'm going to ask my last question before I open up to because I want to leave at least 25 minutes. So I want to ask, this thing is intended for the students. Yeah. I hope the student here should prepare some questions. Well, we're going to go to you first. But let me ask the student sort of related to the student, or on behalf of the students. Yeah. That's in terms of if you're an undergraduate student now, you have several worries, right? You have to worry about how to pick a major. You cannot predict what is happening in science or engineering. You have to worry about your first job. So I would say our students here at UST worries a lot about that. They worry about the grade. They worry about what job they're going to get, whether they will get a job, where they will work. We talk about internationalization. On the other hand, we also have seen a phenomenon just in the last few days. When the first Hong Kong Nobel Prize was announced. So what I read in the newspaper these 2 days is that many students want to now study electrical engineering because of our first Nobel Prize by Charles Kao. So you can see, my interpretation is that students have sort of two minds, right? One is they're looking for inspirations, obviously, a role model, inspiration. But that's sort of the idealistic view. But on the other hand, you have to worry about a practical end, which is, they worry about the job. So what kind of advice would you give a student? You have the benefit of a long career, a distinguished career, where you've seen a lot of successful examples. For example, even when I started, there were no computers. So how would you have imagined? You cannot even say, I want to be a top computer scientist. It didn't exist. So, okay, with that in mind, what would you say? What would your advice be to the students?
Well, that's a very tough question, especially it's a long time since I was a student. And the world has changed. I think there's some fundamental principles. I think I would always advise people to study or pursue what they really enjoy doing, what they really find something that gets them excited. Pursue your own things you like, enjoy, where you hope to, and maybe your talents lie in this direction, and as far as you can. And if you're sufficiently successful in that, then after that you can find some kind of work and living that you can make related to it. It's a mistake in some ways to go in to study something because you think it will get you a good job. It could be, for example, the situation can totally change. The job market may have altered. Then you'll have learned something you didn't enjoy to get a job you don't get. That's the worst of all worlds. If you study something that you like, at least you benefited by something you learned. Then after that, you hopefully will move in a direction that gives you some employment. But the first thing is to really study what you like to do. Second, the reason for that also is that you're usually much better. If you enjoy something, you do much better at it. Motivation is 3/4 of the reason for success. If you drive yourself to do it, you don't like it, you won't get anywhere. And that applies whether you're talking at the undergraduate level or the research level. You must really get some satisfaction from the work involved. And I'm very fortunate. I spent my life doing what I enjoy. That's fine. But at the beginning, I didn't know whether it was the case. I did it because I liked it. And one step leads to another. Eventually, I found there was a career. I didn't necessarily think I would have a career in mathematics. And many of my friends were the same. Many of them actually started off intending to do something else, other careers. But they so much enjoyed the mathematics, they dropped the career and went into mathematics. So I think it's if you focus on what you really enjoy doing, it'll give you more satisfaction now and will open up possibilities for you for the future, and you'll be more successful. Beyond that, the world changes. You can't prepare for everything, but if you do something which you're successful at, which you enjoy doing, it will provide a foundation for you to carry on and move as the times develop later on. But it's dangerous to try to plan your future too far ahead, because the world will change. I mean, many people come from families where they're told you must become a doctor because your father was a doctor, your grandfather. And it's not a good thing on the whole to be forced to go in a certain direction. You should follow your natural instincts, your natural talents, and let them take you where they will.
Was your father a mathematician, and when did you know that you want to be a mathematician?
My father wasn't a mathematician, no. He studied history, then he went into the civil service. There were no mathematicians in my family. In those past days, there were very few mathematicians around. In fact, most of my contemporaries, when they started studying, there was no such thing as a job for a mathematician. The profession did not exist. And if you go further back, there wasn't such a thing as a scientist. There was no profession for science. All scientists you heard of in the past usually started off studying medicine. Medicine was a profession. Once you learned medicine, you learned some science, then you became a scientist indirectly. Nowadays it's changed. And then a lot of people studied engineering, but sometimes they found engineering was a bit dull, they moved into science. So as things have evolved, science plays a bigger part now. But when I started off, there were very few professional mathematicians around. There weren't very small number of jobs. You didn't think of training for that. It didn't make sense. 10 years later, there were more jobs around, but not very many. And in fact, if you go back into the past, some of the most famous mathematicians had a great difficulty finding a job. There were one or two jobs, and that was it.
So how old were you when you knew that you want to be a mathematician?
I knew I wanted to be a mathematician. That's two different things. Okay. When I wanted to be, whether I knew I could be successful.
Okay. Okay, let's talk about that.
Well, I guess in my first year at university, I came top of the examinations. Then I thought there was a good chance of my being mathematics. So until when I went to school, you're good at mathematics, but everybody who goes to university is good. All the best people. So when you go to university, you have no idea whether 100 people are better than you or not. But after the first year or two, then you find out. So then you know where you stand in the sort of potentialities. Then you begin to focus on possibilities. But until that time, it's very unknown.
Well, very good. The floor is open. Okay, now before I go to, I want to really get some question from the students. Okay, but I will start with the vice chair of our council. I have to respect that. Okay, we'll go with that. The second question should come from a student. This is Dr. Michael Mack.
Sorry, I preempt the students' question time. So Michael, I have two questions related. I want to firstly, also about students. When you were a high school student in Cairo, what made you decide to study mathematics or mathematics-related science in the university?
Well, my last year in school in Cairo, when I was about 16, I liked mathematics, but I also liked chemistry. I liked doing experiments, test tubes, and very exciting. I wanted to be a chemist. But then I discovered chemistry is hard. You have to memorize big books. I had a very bad memory. Mathematics was easy. You had principles. You didn't need to remember. So I took the easy course and did mathematics.
The related question is, as a university, how will it inspire high school students to study in this university in mathematics? We can have a Nobel Prize laureate every year, So what should we do?
Well, you have to have good teachers. You have to have people who can teach well and inspire. If you have dull teachers, you lose your students very fast. So you have to have good. Secondly, I think it's important to include mathematics within the larger scope of related fields. Sciences generally, computer science, economics, and show that mathematics is an integral part of our society as a whole. And therefore, if you're studying mathematics, you're not just in an ivory tower by yourself. You are part of a community, and this will give you possibilities to go in different directions, and eventually we're doing something quite different. You might end up, giving weather forecasts and telling when the next typhoon's coming, which would be very useful. But so I think it's important to teach well and not to think of mathematics as an isolated discipline, but part of a larger frame network. This gives you a chance of attracting people in the first place, and then, of course, keeping them. If you make it, the more interesting you can make it, the teaching and the interaction. What I found when I was a student, a lot of the interaction came with work with fellow students. I don't like to take this to all the professors, but very often you learn more from your fellow students. I mean, because you can discuss with them, on a long-term basis, and you learn from them by detailed discussion. So being in a company of good students, similar students, is important. If you're the only person who's doing mathematics, very good, it's very hard. So I would recommend the university should sort of have a reasonable, catchment group and encourage a reasonable number to go on together, because they feed each other.
Questions? Don't be shy. I see a lot of faculty.
There's a hand over there. Young, it's not a faculty.
Maybe you can say your name and whether you're a student or what year and what major, and then ask your question.
Yes, I'm a student. I'm a year 0 student from mainland China, and my name is Liu Zhanxiang. Okay. Because for mainland student, HKUSE only have kind of like a special year 0 for mainland students, or maybe some international students. I'm just wondering because as my personal experience. Students in mainland China, especially in high school, they were educated to be, the main goal of their studies to, pass the examination for, entrance high school, university, I mean. And as you said, as Sir Michael said before, maybe one goal in university is to, explore the potential of your interest or your ability. I think except that, what is the main goal for university? Because for Chinese students, maybe they know there's a very famous Chinese proverb. Actually, maybe kind of like 在明明德，大学之道在明明德. It's kind of like maybe translated it's kind of like to be more moral, or tell you how to become a real human being, things like that. And do you think it's more important to to build a full mind or to build a moral person, or it is very important to study hard, or it's important to know more about the world, about the society?
Well, the question is whether your education should be more narrowly focused on passing examinations, or it should be a broader one, with learning more about life. I think the answer is you have to have a balance. It's very important that you should be a balanced person. You should learn about many things outside your discipline. Learn about how other people live and think. You should learn about other countries in the world. You should have a broad perspective for lots of reasons. It makes you a better citizen. It gives you more satisfaction in life. It makes more opportunities for you, and it's more enjoyable. On the other hand, you should also have to study. The purpose of universities to learn the things from the past, hand down the knowledge of the previous generations. So your job in university is to learn new things, think about problems, whatever field you're studying, and eventually this leads you into one direction or another one. But two things should go together: your personal development and your intellectual development in terms of the subject you study. They should balance each other out. And it's healthy if you have if you're very narrowly focused on your studies. It's not psychologically healthy. You get introverted, isolated, and maybe depressed because things don't go well. It's much better to have have many friends, play games, whatever you like to do, involve yourself in activities, but not so you ignore your studies. So it is a balance. But like all things in life, you have to get the right balance. That depends on you. Not all people will find the same balance. And then you find your own way, and gradually you evolve. In the university, you go to the university, the most formative part of your life. not only the most formative part of your life, but the part where the maximum opportunity of interaction and learning things, because there are so many different people around. You meet students from other countries, you meet people, and so many ideas. You have a lot of opportunity. And the aim is that by the time you finish your 4 years or whatever it is in university, you've broadened your whole horizons, you've learned more, and come out as a more mature citizen, which you may then go on to do further studies. So I think education is a very, very broad-based activity, not just a matter of passing examinations.
Thank you.
Hi, I'm Elizabeth Nanis. I'm a doctoral student in anthropology at Wayne State University, and I'm here as a visiting scholar for the year via Dow Chemical, studying scientific collaboration. I'm very interested in how much you spoke about collaboration and the importance of collaboration during the conversation. And while I understand that collaboration has always been a part of the sciences, I wonder, during your career, how has collaboration transformed over time?
You mean over recent time, over a long time?
During the course of your career,
I see.
What has your experience with collaboration been, and how has that changed or not changed over time?
Well, personally, over my own career, there's been a lot of collaboration between mathematicians and physicists, which is very much my own work, and that's had an enormous impact on many people. But more broadly, of course, all of science in recent years has tended to break down barriers between different fields, and you now get all these combined things, molecular biology and this and that. Science is no longer just physics, chemistry, mathematics. It's now everything is sort of interdisciplinary, and not only between the different sciences, the boundaries broken down between science and the humanities, social sciences. So these barriers, which are originally somewhat rigid and artificial, are now much more fluid, and most universities are constantly trying to make it fluid so that students can also learn different things and not just in one department. And I think that has changed very much in my lifetime. Universities are becoming much more open, and perhaps partly a reflection of the complexity of modern society. All these things are needed. You can't ignore the effect of science on society, and so it's all necessary. So I think there has been a big change in recent time in breaking down barriers, and breaking down the barriers is what you need in order to make collaboration.
I assume you're not a student, but it's okay.
Well, relatively speaking.
We're all students.
We're all students. Yeah, thank you very much for that comment. I was actually going to ask about collaboration. Clearly, as you say, the disciplines have changed, the nature of collaborations, but all collaborations must have a beginning. In other words, an individual group makes a discovery. Then that person will realize the value of that discovery, and if there's, let's say, some technological potential for that discovery, then he goes and seeks out collaborators. So my question relates to this, that do you think there's too much emphasis now on multidisciplinary research for the sake of multidisciplinary research at the expense of what one may loosely term blue sky research? And this is a debate going on in England at the moment about the current government trying to fund projects which are technologically oriented at the expense of perhaps more blue sky. But I'm saying that with a view to what the public responsibilities are, but maybe there's just a little bit too much emphasis on applied and multidisciplinary research.
Well, I think I tend to agree. I mean, I think the collaborative research should grow organically out of the work of the scientists themselves. It should naturally develop, that they require to move from this to this, to mix these together. It shouldn't be imposed from above, really. So I'm suspicious of anybody, governments, university administrators, saying, we want to develop interdisciplinary activity with this and this, and you will combine A with B and so on. And enforced marriage is not usually successful, although I think in some countries it does work. So I think it's better for these things to grow naturally. On the other hand, of course, if you go from science per se to economics, what the country needs for economic development, what technology you may require, you get different criteria. Your country needs to, if you're a country that lives by its agriculture, you need to improve your agriculture. So there are requirements, and which is perfectly correct for a government, which puts money in to say we want to encourage development in this field, and this field needs some new scientific input, so we need to get the biologists to come and help the people in agriculture to grow better crops. That's perfectly reasonable. It comes from an economic necessity or need. But I think what is wrong is for the government to make this a universal principle. Everything should be interdisciplinary, and the more interdisciplinary the better, and you only fund interdisciplinary things, only fund also those things where you can see a direct application. As you know, blue skies research in the long run tends to be longer benefits. When James Clerk Maxwell, who came from Edinburgh, by the way, which is where I am now, developed electromagnetism, there were no applications in view. We live now on the electromagnetic field. So, and of course, these tend to be long-term applications. Very short-term applications are what the governments can see. But the long-term applications only come from fundamental research, which pays off in another generation or two, although sometimes it's faster. So you should distinguish between short-term and long-term. Short-term things, which is what governments worry about because they have to be re-elected next time, if there are elections. These are tied to short time scales and are very limited kind. And it is important to see that current science is put to good use, where it can be. But the really long-term applications of science come further on and at a much more fundamental level.
Yes, I'm Richard Haynes. I'm a chemist, actually. I started off doing chemistry and mathematics in first year, but I actually liked chemistry because I was more experimental.
You said in chemistry.
The world is better off because it was more balanced. Other question? Yes, in the back.
Good afternoon, Sir Michael. Good afternoon, President Chen. I'm a student from business school. Although I'm a business student, I admire the quality that the scientist has presented to us, like perseverance, assiduousness. And I wonder that, there is a very famous mathematician in China too called Chen Jingren. And his experience is quite different from you because he kind of locked himself in his own room and pursued his academic work and quite isolated from the society. And interestingly, quite contrary to that I know that, Sir Michael, you value that the social responsibility quite well, and you travel many countries in the world your whole life. And there is an old saying in Chinese called 行万里路，读万卷书, means you travel many places and just like you have read many books. And I wonder that, have you ever encountered some very influential incidents in your life while you are traveling, which can, inspire you or give you very big influence your whole life, or which can enhance your values of your life? Thank you.
Well, I mean, I've spent much of my time collaborating with other people. This first comes by meeting them when you travel, but then you go on collaborating after by other methods. And most of my work has been collaborative, and I've benefited enormously because if you work with other people who have different interests and skills, you become more, you can do more. So I couldn't have done as much as I did without all the collaborators I've had, people who I've become friends with over a 40-year lifetime. So that arose, obviously traveling has helped to ensure that you meet people, although most of my collaborators I met the first time I went to the Institute of Advanced Study in Princeton. That's the stage when you really form, just taking your PhD, you're very young, you meet people. These are the people you tend to stick with all your life, actually. The subsequent travel is not so important. Opening up your life at the beginning is what's important. Once you open up your life at the beginning with a good university and meeting good people and perhaps going to some foreign countries, broaden your outlook, after that you will find your own friends, your own roots, and the travel will be incidental. But at the beginning, it really does make a big difference so that you can interact. So, but mind you, I should add that all people are different. And science requires people with different skills. Everything requires people with different skills. We don't want to be clones. You don't want, even if you find Einstein, the world would not be a better place if we had, 6 billion Einsteins. I mean, you need other people, so you need variety. And even within science, you need different kinds of people. Some people work by themselves, think very hard about one problem. Some people work across the board. And you need a balance, because some are successful sometimes, some are successful other times. And therefore, it's a good thing that human beings are varied, because there is need for variety. We don't want exactly the same work being done by everybody. So variety is important, and you should be always tolerant about other people's lifestyle. I don't like doing the way he does it. I do it my way, his way. So it's important to be tolerant, to allow people to work in their own way, their own choice, because at the end of the day, we all make our decisions, and without our own choices, we won't be successful anyway. You can't be forced. You're free people, I hope, still.
Angelina, you had a question.
Sir Michael, I think it's widely noticed that mathematical genius and musical genius seem to appear early in life. Also, linguistic aptitude. I wonder if you have a theory about a connection between these aptitudes. And my second question is, do you foresee a day when mathematics can be applied to, say, literature? For instance, computer-generated poetry.
Well, let's see. The danger is when somebody asks so many questions, you forget that. So let's see. Where did you start? Your first question was about
the connection between mathematical genius and linguistic and musical genius.
Two things. First of all, it's certainly true that many people with mathematical ability show it very early, prodigies. There are many famous examples of people who are very, very young, and of course there are Mozarts. And so in certain fields, the talent of an exceptional kind can show very, very young. But I shouldn't say to modify that. In mathematics, there are a lot of people who are infant prodigies who do not go on to become famous mathematicians. Some do, but probably the majority do not. So rapid advance at the beginning is not guarantee long-term success. It's like if you win the 100 meters, there's no guarantee you will win the marathon. Some people can move up as they get older and run longer races, but not everybody. So you shouldn't confuse prodigies with genius in the general sense. It's a kind of genius, form of genius, but it's not. Mozart was successful all his life, but not everybody who's talented as a young person will be equally successful. Secondly, I'm not sure you're implying that there is an analogy between mathematics and music, a relationship. There are many my mathematical friends who are very keen musicians, play. I like music, but you don't want to hear me play. But I think there is some. But people who've done serious sociological study say it's very hard to prove a good correlation. But there's some. I think the thing that is common to them both is they're both very well defined. Music is its own language. Mathematics is its own language. They're really quite separate from a lot of other things. Music is not the same as poetry. And so I think they stand out from other fields because of their sort of well-defined character. Music and mathematics are very obvious what you're talking about. But as for infants of computers, well, I was born before computers. I remember my first computer I saw. It was when I was at school in Manchester, just after the war, and I was taken to Manchester University to see the machine they used there during the war. It was called an analog computer. It wasn't electronic. It was made of wood and cogs, and it was used to solve complicated equations. It occupied a big room like this on a big table. It was quite interesting to look at, much more interesting to look at than modern computers. So I've been there from the beginning of the computer to the present time. Computers do marvelous things, but they do things rather, I think, complementary to the human brain. Things the computer is good at, the human brain is not good at, and vice versa. For example, I think computers can do a lot of complicated calculations very fast. But if there had been computers around, let's say, at the same time as Isaac Newton, I think they would have calculated lots of complicated things in dynamics with algorithms. They would have never invented the calculus. That's quite a different kind of brain. Computers wouldn't have developed the calculus. They would have solved problems, everyone, in an ad hoc way. And you'd have got tables and tables telling you how to do things. But you would never have developed the fundamentals of the calculus. So I think the computers have a limitation because the human brain works differently. It works, and I like to think of mathematicians working actually somewhat similar to the work of poets. I think because the people think that mathematics is just a matter of working like a computer, complicated calculations one after the other. But in fact, it's not the case. Most of the time, mathematics, we dream, we imagine, we make wild guesses, we move around in some stratosphere of ideas, and eventually these come down to something concrete which you can do a calculation. Most of the time, you play around with ideas, and that's much more fluid than computers. Computers don't like that; they want you to be precise. So, real creative work, whether it's in mathematics or in painting or in music, involves allowing your mind to wander very loosely and widely over a large spectrum. And we do the same as that as the poets do. So I'm sure the same way that computers aren't going to produce really fundamental mathematics, they're not going to produce good poetry.
Let me ask the last question because time is closing. That is about the future of science. That's a big question. Now, on the one hand, you must have heard that there are writers and intellectuals out there that says we have come to the end of science. Everything that is, ever to be discovered has been discovered. On the other hand, there are also another school of thought that says all of science is contained in data. So, if we had all the data that Newton had or more, then we would have discovered Newton's law by just analyzing data. Okay, so those are sort of, in a way, in my mind, there are two extremes. What's your perspective on the future of science?
I lost track of your question again.
One is that some people claim we have discovered everything that is to discover.
No, I think,
end of science. The end of science.
Well, I think first of all, that's been said many times over the centuries. In 1900, physicists said that we finished physics. And then a few years later, everything came new: quantum mechanics, relativity. So I don't see any reason why that shouldn't happen again. We're just waiting. Maybe another few years, some other things will happen. So I think science is there are always new things happening, and it's not clear. And what happens is that as you solve one set of problems, you ask more difficult problems. I think basically people say that there's always more to know than what you already know. And so as soon as you learn something, you open the door into the next room and you find a much bigger set of problems. And so I think, I don't think science will come to an end. I don't think mathematics will come to an end. It's difficult to imagine what mathematics will be like in 1,000 years' time. I find it hard, but I think it'll still be there. But so I don't think we reached the end of science or reached the end of mathematics. And if you're worried as a young man or a young woman that you won't get a job because there won't be any science when you finish, don't worry. It'll still be there. And there'll be plenty of problems to be solved.
Very good. On that note, let's give Sir Michael a big hand. Thanks.